Alright students, example number 3 says using first principle prove that d dx of 1 divided by fx is equal to minus of f dash x whole divided by fx whole square. So for simplifying this particular problem, this whole thing is taken as phi x. You can see this phi x is taken as 1 divided by fx. So in place of x, if I am writing x plus h, then in place of this x also we have to write x plus h. So finally, if you have to find out the d dx of 1 divided by fx or d dx of phi x, which is nothing but this, in place of this 1 by fx is written as phi x, we can again use the first principle formula, that is limit h tending to 0 phi x plus h minus phi x whole divided by h. Now as you see, this phi x plus h was nothing but it was taken as 1 divided by f x plus h. So this 1 divided by fx plus h is written over here, and in place of phi x I have written 1 divided by fx, which was taken earlier over here as 1 divided by fx. So after taking the LCM of the denominator, we will be getting this fx plus h into fx in the denominator, and with this, if we divide this whole thing, we are left with fx, which is written over here, this minus sign copied over here. With this, if we divide this whole thing, then we are left with fx plus h, then 1 multiplied by fx plus h gives you this whole thing, and this h is multiplied over here in the denominator. Now if you see carefully, if we take this fx plus h in the front and this fx over here with minus sign, then we have to take a minus sign in the front, and limit h tending to 0 remains as it is. And denominator, this fx plus h into fx is written separately over here and h over here. Now if you see carefully, this whole thing is nothing but it is your fx, f dash x, sorry, means dy by dx, means f dash x is written over here, and h, as h tending to 0, then this becomes fx into fx, which is nothing but fx whole square, which is written in the denominator. So this is what you have to prove. I hope you all have understood. Thank you.